Now we continue on with our study of truth values, and this is just a little reminder of what everything means. If you have P and Q, this is only true if both statements P and Q are true. If you have P or Q, this is true when at least one statement is true, or it's only false when both statements are false. And then if you have P implying Q, this is only false if specifically the first statement is true and the second statement is false. So, in classic math fashion, we're going to push it a little further to something a little more challenging. A set with two elements, or P and Q, has four subsets. A set with two elements has four subsets, if you remember from when we were doing our set theory section. This is the same thing as a sentence with two statements. A sentence with two statements has four truth possibilities. So, it only stands to reason that a set with three elements, which has, if you remember, 8 subsets, it's always a power of 2, a set with three elements has 8 subsets, which tells us that a sentence with three simple truth statements, with three simple statements, has 8 truth possibilities. And so what does that mean? Well, let's work on one. Let's put together a truth table for one of these three sets. So let P, Q, and R represent the following. A student misses a lecture, a student studies, and a student fails. That's P, Q, and R. So now we have the statement, if a student studies and does not miss a lecture, a student studies and does not miss a lecture, then the student does not fail. The student does not fail. So let's build a truth table for this with three statements. And we'll see that it is a little more challenging, but it's still doable. So I'll build it up here. So I'll write Q and not P implies, what does this imply? It implies not R. And let's try to build this truth table. And now this is going to be the hardest part, this setup. Everything else follows the same way, but this setup, we know that we have 8 possibilities now. So I'll write my P, my Q, my R. And now we have 8 possibilities. So P could be true. And you know that we're going to have 4 trues and 4 falses if we have 8 different possibilities. P could be true or P could be false. And it already might look a little scary with all these T's and F's, but you'll see that it's very doable. Q could be true and R could be true, or we could have Q is true and R is false, or we could have Q is false and R is true, or we could have that both statements are false. And you see that I just built the regular truth table. This is the truth table we usually use in Q and R after I set up P. And now I'm just going to do it again, because P could be false, and if P is false, then we could have Q true, R true. Just put a line here. We could also have Q true, R false. We could also have false, false, and then true, false. So the setup for this, the easiest way to set it up, this is what I think in my head, is first I just remember that P is 4 trues and 4 falses. Then I set up two set truth tables. Here's the first one, here's the second one, in the QR spot. And if you do that, you successfully have set up your 3 statement truth table. Now, if when we're solving our statement, we follow the same rules that we've been following, we follow the same rules that we've done in the past. So we have Q and not P, so I'm going to need not P. And not P is just going to be 4 falses. False, 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 false. Then true, 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 true. Now I can do Q and not P. Remember, Q and not P is only true if both Q and not P are true. So let's circle Q and not P. These are the two that we're looking at. And if they're both if either of them are false, we end up with a false. So we have a false here, definitely a false there, except we have two trues here, then we have a false here, and a false here, because we have at least one false in those spots. And let's keep everything clean. So we already have our Q and not P. Now I see that I'm going to need not R, so I'll do that next. Not R. And not R is just going to be the opposite of what R is. R is true, false, oscillating, so I'm just going to do false, true, oscillating. False, true, false, true, false, true, false, true. And it is very easy to mess these up, so you have to be careful, especially with my handwriting, which you all get to suffer through. And now I just do our final statement. Remember, when you have a conditional, what's the rule for a conditional? In fact, I just wrote it. A conditional is only false if the first statement is true and the second statement is false. So if we're looking at our last two categories, we have that the first statement's false for the first four of them. So we're definitely going to have true, 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 true. In fact, the first statement's false down here too for the last two. And then the middle two are the ones we have to worry about. We have a true, false, so we have one false here. And then we have a true, true, true right here. And that is our three-statement truth table. That's how you do a three-statement truth table. So PQ gives us 4 truth possibilities, but PQR, when you include the R, when you add one more statement, you end up with 8 truth possibilities. So now let's walk through the steps of constructing a truth table for the following statement. I study hard, I ace the final, or I fail the class. I study hard and I ace the final, or I fail the class. So we begin by representing the statements as letters. We'll say P is I study hard, Q is I ace the final, and R is I fail the course. PQR. Then we turn the statement into logic. So we have P, I study hard. Then we have the and symbol with the word and. Then we have Q, I ace the final. Then we have an or statement with the or. I always use parentheses when I see a comma, because I see that the first half is happening first. Or I fail the course, which is R. So now we have our setup. And then once we have our setup, we can construct our truth table. So let's construct our truth table. I'll do it up here so that we can see everything that is going on. And let's do PQR. And all my truth values are true, 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 false, 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 false. And then once I have that written, I can just construct 2 of our normal truth tables. True, true, false, false. This is going to be true, false, true, false. Then once again, we have true, true, false, false. And this is true, false, true, false. And setting up your truth table, setting up your 3-statement truth table is truly the hardest part, because then you just follow the rules. For example, we have P and Q here. What's P and Q going to be? P and Q is going to be anywhere. It's going to be true anywhere that we have 2 T's. 1 in P, 1 in Q. So the first piece is true, because P and Q are both true there. P and Q are both true in the second spot. But then we start to get falses. And in fact, we have a false in one of the spots at least for all of the rest. So we have a false here, a false here, a false here. False, false, false. Now we have that and statement, P and Q, and we have that or R. So now we'll follow the rules of or with the thing that we just did and R. So the 2 columns we're going to be looking at are these 2. And in an or statement, It's true as long as we have a true, as long as one of the pieces is true. So we have a true here, we have a true here, a true here, but we have two falses here, so that's going to be false. True here, two falses here, true here, two falses here. And this is our truth table for the statement, I study hard and ace the final, or I fail the course. And this is how you do a 3-statement truth table.